Hi, everyone, and welcome. I'm very glad to be here at Conf42 DevOps 2025. This is the first Conf of the year. Today, I want to talk to you about how you can pimp your Kubernetes troubleshooting skills using something called K8sGPT. We'll explore how this AI-powered tool can bring real-time insights and help you resolve your K8s issues faster and more effectively. But before we get started, let me do a quick intro. My name is Cohere, aka CloudDude. I'm a founder and principal consultant at Cloud3. I have almost 2 decades of experience in IT and Oracle tech. I specialize in multi-cloud operations, DevSecOps, and a tiny bit of AI inference. There's not much more to say that I'm a huge cloud and automation fan, and I share all my labs and discoveries on my blog. Now it's cloud.ca/blog. And in my GitHub repos, that's github.com/workdba. That's not a handle. Sorry about that. I'm also the host of Tech Beats Unplugged podcast since a year, which I'm very excited about. You can find a cool episode where I hosted Kelsey Hightower chilling about DevOps for almost 2 hours. So please check the QR code out if that content speaks to you. Okay. Now that we're done with the intro, let's get to the reason why we're all here today, right? Which is the agenda. So what are we going to talk about today? Well, first, we'll talk a bit about context and compare what AI is good at versus traditional troubleshooting methods and challenges. Then in section 2, we'll learn more about what's K8sGPT really. We'll explore key features, benefits, along with some specs and AI backends and installations. Then in section 3, we'll dive into all the K8sGPT commands you need to work with describe basic and the operator architecture because, there's a CLI and there's also in-cluster installation. And finally, we'll have some fun with a little demo that I will be running. So I hope you will like it. Okay, but let me start with the meme, actually. So, of course, AI today is stirring up endless headaches across tech industries. I don't know if you heard, but Mark Zuckerberg recently announced AI will replace his mid-level engineers by 2025. That's a scary thing to tell your engineers if you ask me. But hey, this is the same guy who burned almost $50 billion on Metaverse, right? Remember? So who's right? Will AI replace your job? Maybe, maybe not. But it certainly won't hurt you to use AI today to do your job better. At least that's my opinion. On the flip side, you don't want to completely depend on GPT for your technical growth in a company, right? Because it's not healthy and fundamentals are still important. So the key is really finding the balance between the two. All right, done with the meme, back to business. I am not going to talk about what is AI, but it's important to highlight some key events or concepts, right? This is just a language model history. That's like a timeline of what happened and when, but I could also we can start to explain neural networks, right? So what is a neural network? Well, a neural network is a network that helps analyze different complex data like text, image, video, or audio. But there are many types of networks depending on the data, the type of data that you have, right? For example, for analyzing images, you'd have to use CNN, which is convolutional neural network. This is also used in your Teslas to avoid obstacles. For text, you would need to use RNN, which is recurrent neural network. That's the ancestor of current language models, right? But back then, there was no record, for example, of the order of the words, and it couldn't handle large text. So it would forget the first word by the time it gets to the last one, right? And it was also running sequentially. So what really happened after that period? Well, although OpenAI opened up shop in 2015, what's considered the game changer in this LLM journey is the introduction of transformers architecture, right? Back in 2016 and 17 by researchers from Google and University of Toronto. The paper was called Attention is All You Need. And this really marked the shift from the sequential to self-attention, bring more features like positional encoding for word ordering, which is very important, and also attention, which allows to a more accurate translation of the words. Let's say, for example, you take a sentence in English, a European Union, right? You would like to translate into French. Well, in French, it's not neutral like in English. It's l'Union Européenne, right? So this is a completely different gender, right? So the attention is attached in the right gender link between the words or flipping them due to the training data. You also get self-attention that allows the underlying meaning of the words. I'm talking about grammar, gender, and tense-aware and context-aware synonymous, all that kind of stuff. And this is on top of handling huge data sets of gigs and terabytes. So the transformer was the discovery, the big breakthrough that laid the groundwork for subsequent groundbreaking models up to the GPT and nowadays models, right? And beyond, right? There's a link actually in the slide if you want to learn more and dive deep into it, into the timeline. But bottom line is the transformers is why we're using ChatGPT today, right? So I hope it was informative enough and it gave you a glimpse of the timeline. Now let's talk about what AI is great at. It is, of course, very good at pattern recognition, looking at the repetition, a lot of noise, translation, translate noise into a signal, and predicting the next token, for example, right? But that's also funny because the problems we usually struggle with as SREs and K8s clusters are also pattern recognition, translation, and prediction, right? For example, when you consider the failures from your workload, the nodes, the backend, and how to actually spot these patterns. We have also challenges in how to find out how did something go wrong and why, which can be very complex in Kubernetes clusters, right? How to correlate those errors throughout the stack. We also have trouble forecasting or do some capacity planning. And let's say you have a stateful set, like I'm just like showing an example. You have a PVC failure because something went wrong with any other layer, like the storage, right? When this happened, you got a lot of reasons that could lead to this issue. I'm taking one managed cluster in the cloud, for example, OCI. It could be in any cloud managed cluster. Let's say that issue that you can have in a PVC could be because of the wrong storage class, or it could be because of the block storage was used with the wrong file system, like ext4 instead of XFS for the PV with the CSI plugin, or somebody just went to the console and changed the parameter of the file storage that was dynamically generated or created by a CSI plugin. So all of these can happen, can be the source of your issue. But how do we correlate all this today? Like oftentimes it's painful as this involves very deep knowledge and in every layer of the stack. And obviously, right, so once you pass the euphoria of day zero after deploying a cluster, moving all your application in your post, with time, then you realize how painful it is to troubleshoot clusters in production. And the more clusters grow in size and complexity, the more difficult spotting the root cause of issues becomes, especially when multiple components are added every day from different teams like ingress, storage, services, CRDs, operators, you name it, are involved. Each time you add a Helm chart or an operator, things can break. And of course, first thing you do is check the error message or traces, but they're often cryptic. Like you wouldn't even know where the problem is coming from while sifting through the piles of logs. Thing is, many Kubernetes issues are Linux issues undercover. You have sometimes ulimit issues, you got system config issues and OS issues, right? And the sheer volume of logs and events and metrics in Splunk or any other login system that need to be analyzed makes the remediation painfully long. And that will slow down your operations or causing even longer downtime as we all experienced in the past. And to make matters worse, all the best SREs that you have, they hold that knowledge of how every piece works, but could never put that into paper or documentation because it's so immense, they don't have time, or it's based on a decade of experience. So it stays in their head forever and never shared with the junior SREs, right? So imagine how challenging the onboarding could be, or the first day on call for a junior. Pretty challenging, I must guess. And as shown here, once the failure happens, we have only limited window to filter the signal through the noise. And God knows we have a lot of noise sometimes to get the clarification, right? So this is the kind of issues or conundrum SREs find themselves into during the troubleshooting. But what is interesting also is that there is always a pattern that can be extracted from these use cases throughout the lifecycle of the cluster or of the workload. So what if we can codify those repeatable conditions for those failure modes in order to get closer to a best guess or a best effort type of advice, right? So what can we do about this? Well, fortunately for us, some people start to work on the issue. And this inspired people like Alex Johns, and a bunch of maintainers to create K8sGPT. So what is K8sGPT really? Well, simply put, it's just a tool that scans your cluster, diagnose and triage your issues, and enrich it using LLMs or AI backends, even if you're not seasoned expert. Think of it as a guru that would filter the relevant info from the noise on your behalf and come up with advices to fix your problems, right? Sounds like magic, right? So in a nutshell, this project is an open source project that was donated to CNCF, I think, a couple of years ago, with more than 92 contributors, 6,000 stars in GitHub. Feel free to give it a star too. And it allows fast triage with AI health and issues analysis. The best part, it has an SRE experience codified into 19 analyzers. We'll talk about it deeper in the next slide. And it converts the complex signal into understandable suggestions. This is like the best part, where like you get the suggestions that is understandable and ready to use as solution. It also supports over 12 AI endpoints. I'm saying 12, but maybe it got bigger, right? So think of any type of AI endpoints you could imagine, right? So they support OpenAI, local AI, Cohere, Hugging Face, Ollama, and other cloud AI solutions. I'm talking about Azure OpenAI, Amazon Bedrocks, Google Vertex, OCI Gen AI. So the whole package. And last but not least, security, because security is important. So K8sGPT also integrates with dynamic scanning tools like Trivy for a CVE review or scanning, which is pretty cool. It's also integrated with Prometheus. I'll talk about further plugins in the coming slides. But as I say, like, K8sGPT gives Kubernetes these superpowers to everyone, right? So because it makes the process so easy through a one-liner instead of sicking through so many commands, that it becomes a no-brainer for anyone who's stuck and needs help with Kubernetes anywhere, no matter how junior you could be. And this can save you tons of hours, that's for sure. Key features of K8sGPT. Well, the bottom line you need to remember is everything is built around work smarter, not harder, right? So we already said that it has a codified SRE knowledge, the guru part, that knows what to look for, where to look for it. And also the AI would cut through the noise and give you that suggestion. But that's not all, because K8sGPT is only paired with AI to improve the text output. The real secret sauce is the built-in analyzers. And there are 19 covering most of Kubernetes resources, right? So we can see here, you have replica set, service, ingress, stateful set, node, network policy, pod deployments, PVCs, you name it, right? So all of those are actually analyzers. They call them filters as well, that will allow K8sGPT to get the information needed from those primitives from the API server, right? And the good thing is that you can even build yourself new and custom analyzers if you want to, because it's supported and you can contribute back to the project. So that's the cool part of it, right? And then we have anonymization. So we know that usually, even when you have an issue troubleshooting with vendors, they can allow you to sanitize the content. You don't want to send your sensitive data to your vendor, let alone OpenAI or Cohere, right? So KSGPT offers a way to mask the data. As you can see here, you have the error reported during the analysis. We have a stateful set with a full name, right? So that's the original data that's not masked. And what GPT does when you specify the anonymization, it will mask that data. That name will be masked before being packaged into the payload and then sent to the AI backend. Once it's received and then the inference is run on that input, the AI backend will send back the information, and GPT will actually process that solution return to the user and mask the data that wasn't masked. As you can see here, you can see that the final output returned to the user has the right name, so the user would know which resource are we talking about, right? So that's the cool part. But be aware that some analyzers, not everything is masked, unfortunately. So you get some resources like events, replica set, pod, PVCs aren't, which might be problematic in some situations. But what option do we have to solve the problem then? Well, I do have one, and that's just me, but you can go fully private using local LLMs, because you can have an inference server within your data center, and you wouldn't have to worry about sending sensitive information to OpenAI or Cohere because everything is within your data center. So that's more safety. Anyway, we also have remote caching. So remote caching also allows to offload the cache data to a remote storage service like S3 or Azure Blob Storage, stuff like that for persistency, and also sort of relieve your server from storage pressure. I'm talking specifically for cases where you have KSGPT installed as an operator, right? So you will just move that storage out of your nodes in order just to release a little bit of space, right? And what are these data, right? So I was first asked myself, like, what kind of data can be cached and can be offloaded? Well, it could be the analysis results, it could be the diagnostic data, and it could be the K8s config data, right? So specifically for in-cluster installation, right? And then we have the integration. I already spoke about the integration. You have integration with Prometheus, which allows KSGPT to leverage real-time metrics in order to give more insights, more context to the AI backend so they can give the best solution, right? So we could scrap those metrics from Prometheus server. And you can also leverage Trivy with the integration so you can scan the cluster for potential vulnerability and also misconfiguration cases as well. So, and I actually could have put other plugins because it's also supporting Kyverno and Kera as well, just so for you to know. And the way to activate an integration is through a simple command, which is KSGPT integration activate Trivy. And then right after that, you can just do a filters list, and then you can see that you have two new analyzers. They're not analyzers really because they're linked to the plugin that was integrated to it. That's why you have the parentheses and integration. So you can run two types of analysis, which is a vulnerability report and for CVEs and a config audit report as well. And that might prove to be very useful if you want to do everything in one location. And of course, the LLM AI backends, you can see the list in here. It's very, very exhaustive. But if you find a backend that was not listed or supported, feel free to open an issue or reach out to the team. But to be honest, I'm pretty okay with this list because it's very, very exhaustive. So that makes me happy. If I want to choose an AI backends any day or change it, I'm sure I'll find it in the list. I just want to share an example. Let's say OCI generative AI from Oracle Cloud. What you would need to do is have a credential to have access through API to your cloud provider. And then the second command is KSGPT auth add backend. You specify the type of backend, which is OCI. And then you'd already have a model before. So you specify the ID of the model and the compartment ID as well, which is like resource group in Azure or a project in GCP. So it's really straightforward. And right after that, you can use KSGPT to analyze issues to be solved and use the explain flag and the backend to specify which backend you want to use to get your solutions. In terms of installation, very straightforward again, cross-platform. If you want to install in Red Hat or Enterprise Linux Fedora, there are RPM available. If you can run a brew install if you're in Mac OS, or you can install in Ubuntu through a Debian package. You can even install Windows in WSL within Windows as well. So it's pretty ubiquitous in terms of installations. And all you need after that actually is have access to your Kubernetes cluster, have a context through kubeconfig. And after the installation of KSGPT, you may need to eventually, if you have access to a backend that requires an API key, need to create your API key. As you can see here, and I just chose OpenAI, but it's it's the same everywhere. They now recommend to have project API keys, maybe for sort of a security purpose, or to keep track of all the keys that you create. And once you create that key, you run KSGPT auth add, and you specify the backend. You don't need to specify OpenAI backend because it's a default one. So if you run KSGPT auth add, it will just ask you for the OpenAI key by default without even specifying OpenAI. Once this done, you can see that the status of the authentication or the backend is now active. That means that you can use it to explain on top of the analysis, right? So you can run the KSGPT analyze, and you add the explain flag plus the backend flag. Again, OpenAI doesn't require to put the -b OpenAI because it's the default one. If you don't specify any, it will go directly to use your OpenAI backend if it's defined. One more thing to notice as well. So once you installed KSGPT and once you added one backend, there's a configuration that is stored in your user directory. So let's take Linux, for example. It's under the home directory .config ksgpt.yaml. And one thing you need to know is the API key is stored in plain text. Right. So that's one of the things that I noticed. So like there is no encryption currently enabled in order to sort of mask that type of secret, right? So you got to be mindful of this, or maybe try to play with the privileges of this file, or use an elevated user in order to run GPT eventually. And again, I also always have my solution, my option, which is just go fully private and use local LLM inference within your data center. And when you have that, you don't need an API key. You will just have like SSL configured, and you have firewall, and then you'd be safe on that matter. You won't have to store any API key out there. There won't be any secret sprawl. All right. In terms of commands, what I like about this CLI is that it's straight to the point, right? No fluff, just what you need. So in terms of commands, it's just like 10 beautiful and easy to remember commands. So let's explain a few useful commands and flags so we can focus on what matters. The first one, we just described it, is the auth, right? If you want to add a backend, we did that with OpenAI, right? You can add, list, and remove an AI backend. And after that, you can eventually get some inference from your backend when you run KSGPT. The second one is analyze. So analyze would just allow you to find problems within your Kubernetes cluster and provide you with a list of issues that need to be resolved, right? So it's like events or logs on steroids, right? It will just show you the issues that need to be resolved. It will not reply. It will not give you solutions. Why? Because at this point, you're not connecting to your AI backend. So right here, there's just a list of issues that are listed through the KSGPT with the analyze. After that, you have the filter. Filter, we already said that we have 19 analyzers, right? So you have to specify which analyzer you want to run, because sometimes you have a multi-cluster environment, or you have many namespaces, different teams with 20 teams with thousands of resources, different type across the cluster. So you don't want to run just the analyze explain, especially if you add explain, which is crazy. So you want to run it based on every type of resource in your cluster. You want to be a bit more specific, right? Just to reduce the amount of time it will take and also reduce the amount of output you will get, right? Because if your cluster is filled with issues, then like it would take 3 or 4 or 5 pages, right? And that's not what you want. And now this one is special because this is where the magic happened, right? So explain or -E is the explain through AI, right? So this is the flag that would trigger the communication with your AI backend, right? So from this point, you're actually starting to pay. If you added your API key from OpenAI or Cohere, if you run a command analyze and you added explain, that's where you communicate with the AI backend and get some info, right? So before you won't pay any, but at this point, that's where the counter actually is starting to run, right? Because it's an API call to your AI backend. After that, you have backend, obviously, because sometimes you happen to have, good for you, Cohere, Anthropic, and I don't know, it could be even Grok if you want to, right? You have all of them defined, and you can choose which backend. The default one is OpenAI, but you can nothing stops you from using another one. And one of the advantages is that you're actually building your own benchmark based on the quality and accuracy of the solution that are provided. So like you can compare OpenAI with Anthropic and see which one is answering better to you depending on the use case. And you can also think of it as a second opinion, right? So it's like when you go to a doctor says, yeah, we need to go for amputation. And you're like, oh, you know what? I might need another opinion. So I may ask another doctor just to be sure, right? So that's also a very interesting feature. We talked about integration to activate, remove, or list the integration, tree V, or whatever other plugin available. And then we have -D or with doc. This one is cool because it's a no-brainer. Sometimes you just want to attach the documentation. So whatever issue or a filter analyzer you choose, you can add -D, and then it gets you the info, the documentation related to the resource you're trying to find a solution to, which is kind of cool. So instead of Googling, you're just having it in the same command. We talked about anonymized. It allows you to mask your sensitive data. And then we have namespace, right? I already talked about the filter. So you can filter the type of resource, but how about filtering the namespace? Because sometimes you have so many namespace in a cluster because of so many teams, right? So, but if you're actually just responsible for one namespace, there was an issue in a namespace, and you want to check or get some solutions regarding an issue with that resource in that namespace, that's your go-to shop. Actually, this is my favorite. Combining namespace and filter is like the best you can think of, which makes it very, very more specific and granular in your research, and also it's faster for getting the answer. This one is new. This is the stats flag, which actually is only available since the version 3.43, not before, right? So it's a very recent addition. And this will allow you to display statistics of each analyzer run, right? So you can just show like how long it took you to run the analyzer for this or that type of resource. You can see here that some of them take milliseconds, other take seconds to minutes, depending on your workload. But it might be useful if you're trying to troubleshoot KSGPT analysis at some point. So that's kind of cool. All right. So in terms of architectures, there are two. I already talked about the CLI, right? So the CLI, you can install it in any operating system, but it's everything. It's process-based. It's within the host where you run it, right? It's not inside the cluster. So it's a binary, as you can see here. So you can have within the binary, you have the analyzers. And when you run it, analyze, and you filter a pod, one of the analyzers will be chosen, and that analyzer has actually a bunch of primitive actually that it gets from the API servers. related to the type of analyzer. As you can see here, like you have the pod list, advanced, status, right? And all this is actually sort of gathered, compacted, and then given into making it easy to build the results so you can send it into, package it, and send it as a payload to your AI provider, right? So analyzer fetches the data, organizes it, packages it. You got the built results that can be run with the analyze. And then if you added the explain, it will send all this information to the AI provider. The inference would occur on that input. And then at the end, the enriched results are sent back with the solutions. That's actually the main loop of KSGPT with AI. And at the end, the user has access to those final suggestions, right? But there's also KSGPT operator architecture. Why? Because this happens when you install it in cluster. This is what we call in-cluster installation, right? So I'm just trying to actually show you the components. So we have the case that I will explain, KSGPT config, KSGPT operator, and then we have the deployment with the analyzers, right? And oops. So this has access to the API server, as I explained with the binary version, and you will have also access with whatever integration that is available, like Trivy or Prometheus. So we'll scrap the data, the metrics from Prometheus. You can run Trivy scans through GPT, through KSGPT, and then the analyzers will just build those results, send them to the API for inference, and then after that, it will bring back the analysis result. One thing you need to know is that there's a requirement to install the KSGPT operator. So the requirement is to install the operator through the Helm chart. So this does nothing, just install the operator. Then you will need to create a secret to store the API key of your AI provider. Why? Because the CLI, right? You don't have to do it anymore. We don't have to store it or do it interactively like with the CLI, with the binary. Everything is stored within the cluster. So API key has to be a secret. Right after that, then you can install the config object. I also talked about KSGPT config, right? So this object, which is a KSGPT resource, can be run. It's just a manifest that you will run and will help the operator create a deployment and a bunch of CRDs. And if you want to upgrade, you just change the value of the version of KSGPT in that manifest, and it will upgrade it for you automatically. And then, so the operator will allow you to hold primitives that contain the suggestion return from your AI model, right? So instead of having the result when you run the command in the CLI, now it is stored within special CRDs that are called results, right? So these CRDs are called results, resources, and they can even be sent to a Grafana dashboard. I can see here on the left side, right? It can be sent to Grafana, so you can see it within one of the dedicated dashboard if you enable it in your Helm chart, right? That would be super nice because instead of like running kubectl to get the results, you can have access in a web browser, right? And just want to show you like the format of that kind of resource. Here, it's a simple example. So we try to deploy a pod with like a fake or wrong name of image, and then the scan happened automatically. So we didn't have to run anything as opposed to the CLI. And after that, it was directly sent to AI, and then AI got the information and then sent back some suggestions. As you can see here in the solution, check the image name, ensure the image exists, blah, blah, blah. And this is basically like a simple back of pulling image issue, but that just shows you that these resources will be created automatically, and then it will be just pile up actually as a resource ready to be accessed instead of just running a command separately. This is not a diagram, just to show you that the KSGPT deployment has pods where the analyzers would run and communicate with the API server and the Inference API server. There's also a way to connect with the dual remote caching and also send notifications to Slack as well, right? So it's pretty much integrated, to be honest. I was going to run a GIF, but there's no way I can play it. So this is the last frame. As you can see here, we have two resources. We have the controller manager operator, and we have the deployment when you deploy the KSGPT config. Right? Demo time, right? So hopefully I'm sorry again if I took too much, but I really want you to have enough background on the tool and also on the challenges and AI and every single feature or use case. But I may do something fun right now. Maybe we can play something. We can run some commands for you, right? Let me see what I can play. All right. Okay. So I think what we can do here maybe is what I want to tell you is that right now in my terminal, one of the prerequisites is installing KSGPT. And also I have a kube config that is already set up. I have access to a managed cloud cluster within, and my version of KSGPT is 0348. That's the most recent one, right? And now we can start to play with it. So one of the first command that I may need to run is KSGPT auth list, right? You can see here that there's a default OpenAI, but nothing is configured yet, right? But if I run it here, this is not the terminal where I already configured my backends. I have OpenAI that is defined and Ollama also that is defined, okay? Right, so, but if I wanted to enable something, I could enable Ollama because I have actually a bunch of models that are running. They're all quantized models that are running within my laptop. I have like just a tiny graphical card, but they can still run and I can use it with KSGPT easily, right? So what can we do? Well, I'll share my repo with README. You can see here that there's a way to add the new backend. So I'm just copying it here. So what that means is that I'm choosing Ollama as a backend. I'm choosing the model because this is Llama 3 latest, right? I want to specify the model. And also I'll specify the endpoint, right? So if I click here, I come here, right? I could run this, right? Ollama, that's as straightforward as it can get, right? If I do auth list right now a second time, you can see that Ollama has been enabled. Now we have Ollama that is active, right? So it's enabled. But let's get back to like the kind of analysis that we can run, right? Now, simple example. I'm not going to do something, crazy, right? So we have just a pod, and I put that wrong image name, right? And I tried to deploy it, right? And it was in a specific, I call it broken namespace, just to be sure, right? So if I get the pods in here, we can see that we have a image pull backup already, right? So the first thing you can do is, I can run it here. And then if I run it, it will actually, no, not this one. Okay. So I specify the backend, which is Ollama, and then it will run. And if I duplicate this one, right, see here, it's taking its time because obviously it's locally run. So it's taking its time and I'm sharing my screen. So I think there's a kind of, it's capping out a bit, but I can also do that and call in OpenAI because I also happen to have that backend active, right? So let's see. So like this one was super fast because it was OpenAI, right? And then it would just tell you that's the analysis part. And then here it gives you the solution. Same thing that you've seen earlier. I didn't want to do more, right? But in the meantime, I can actually run, the last thing I could run is this one, vulnerability report, right? I can do this and I can try to explain it, right? And if I explain it, I can use OpenAI to explain it as well, but it might take some time, right? So if I do with that explanation, it will just list all the CVEs that are actually triggered in or existing in my cluster. You see how many we have, right? But if I want to run the inference on it, just have the suggestions, this is the kind of CVEs you can have with the solution. So the green part is the response from Ollama eventually, right? Because there you go. So this one is Ollama, and we have more or less the same. See, like this is an answer from a local open source model, right? And this was from OpenAI, right? So they're not, depending on the issue, right? But of course, there's a better quality when you pay from OpenAI, but it tells you that you can run easily a local inference if you want to sort of manage your expenses and use local for specific issues and OpenAI for others. But this is just an example. Let's say, for example, the CVE 45337. You see, it's about, I think it's about OC4G or something like that. So if I come here, it's really hard to see what is need to be done, right? But the advantage here is that KSGPT leverage Trivy, and then you send the message or like the payload to AI, and then your LLM would just give you some solutions, right? As you can see here, update Apache Log4j to version 2.19, consider using a more secure login library, blah, 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 right? So this is the kind of information that it can give you, whether it's analyzing resources based on issue, as I said, right? Or based on vulnerability or misconfiguration, right? So I think I'm done with the demo. I don't want to do more than this because it's already too much. And the new project that the team has is called SchedNext, right? So what is sorry about the name, but like what is SchedNext is a Kubernetes scheduler that uses insight from KSGPT to make a intelligent decision about where to place your workloads. Instead of default scheduler scoring that is existing by default, like the vanilla version of your scheduler, you can use a SchedNext in order to like smartly place your workload. So maybe you don't have any topology key defined, for example. So SchedNext will actually just help you like dynamically schedule the resources based on like recent event, which is not always maybe accessible to the basic, so the default scheduler, because they rely on like some very basic scoring. So this is the current project that is integrated also with KSGPT. So feel free to give it a look. But in the meantime, thank you, everyone. I know it was too much. If you want to reach out to me, again, Kosela, I work at CloudTrail. You can reach out to me on Twitter or LinkedIn.com as well. This is my GitHub repo. So thanks, everyone. And that was amazing to be with you. Appreciate it.